Hi everyone, I'd like to show you my 1B1 project. I'll show you the actual usage of it, but I actually think that the implementation is what I'd like to emphasize. So after showing you the gist of what it's doing, I'll walk you through the code base and some of the properties of this implementation that I think are really important for apps that integrate with Mesh. So to begin with, we will run task dev, and this is going to launch three separate tasks. The first is going to compile all of the packages of this TypeScript monorepo in watch mode. The second is going to launch our web server. And the third is a Vite dev server, so using Vite for the front end. Let's open it up on port 5173. And to begin with, there's nothing. And that's because we actually need to log in order to have the user ID that we can validate on our backend and use in generating the link token. So we'll sign up for an account and it's going to take us to this Clerk login. I'll input my phone number and then I'll come up with a password and we continue. And I see the verification code on my phone, so I'll enter it in here. It's 648807. And then it redirects us to localhost. And now you see that we have these two cards. One is for MetaMask and one is for Coinbase. We also see that we have this drop down here. But for now, what we'll do is we'll connect MetaMask. Prompts us, click accept, open MetaMask. I've already gone through the permission screen on this device, so it's not actually opening MetaMask right now, but it would if I hadn't. And then we'll open Coinbase. For this, I am going to have to go through their auth. I trust, allow access, done. And you see that upon having given access, we no longer see a connect button, but instead we see a send button, and it has the hard-coded amount, so 0.001 ETH. And then the balance within that wallet. And we see the same thing for Coinbase, except with my Coinbase balance. Let's click on this. It opens a modal. It describes the action, which is previewing the transfer. If we click preview, it'll show us the raw JSON from the preview endpoint. And then we can click execute. It's asking for the MFA code now. And enter. And finally, it shows the raw response of the transfer execution. Now, with MetaMask, it would be a little different. My understanding is this would use the create link function from the link package. And my understanding is we're not supposed to do it this way for the 1B1 exercise. So for now, I'm only showing you the Coinbase, but hypothetically, the implementation for MetaMask would use create link. Now I want to go into the implementation a little bit. So the first thing that I want to share is that based off the OpenAPI spec, I generated a whole bunch of types and in fact generated a client. And this was really important to me because the existing Node SDK doesn't provide mechanisms for asserting the shape of the responses from the Mesh API. And there are certain inconsistencies in the OpenAPI spec, therefore there are inconsistencies in the types that are generated. And being able to do this runtime type checking of any of the responses actually called out some of these issues that would have otherwise caused me confusion as I was developing. For instance, I was running into an issue with amount of custom client fee. This is inside of the preview transfer result, and initially it was just number. However, the API actually gives us a string. So we have to say number from string. So what the API is going to get back is string, and then we decode it into a number. So that's the value we actually want to interact with. Inside of my handler implementations, I was able to use this experimental client to fix issues like this, where indexing into some data that I know exists when the response is 200, for some reason, the OpenAPI spec, when used with standard CodeGen tools, produces types that are inaccurate. And so here I was able to get around that just by indexing into the thing, which for some reason is now represented as possibly undefined, and then say throw an error if it's null so that we can interact with the actual value that we want, which we know is going to be present, and ignore the possible error. Another thing to note is whenever we start up the server, we're immediately going to get the Ethereum network ID and the integrations list. And then from that integrations list, we're going to extract the Coinbase and MetaMask integration IDs. So we never pass these along from the client, and we never hard code them. We get them every time. You might also notice that all of my handlers are strongly typed. So even if there were like headers, query parameters, path parameters, etc., all of that's going to be strongly typed according to this domain package where I lay out the entire shape of the API. So these are all of the endpoints that I implemented. There are a few endpoints that are worth going over. I think the main ones are this save Coinbase tokens and save MetaMask tokens endpoints. So the gist of these is that inside of our handler implementations of save Coinbase tokens and save MetaMask token, we're receiving the token or the token and refresh token in the case of Coinbase from the client. And then we persist it in a database and associate it with the currently logged in user's clerk ID. We get the current request, access the cookies. From the cookies, we're going to access this session cookie. We're going to, if it doesn't exist, return undefined because there's no logged in user. Otherwise, we're going to use this verify token function, which comes from clerk backend. We're going to take that sub, which is the user ID, and we're going to pass, and we're simply going to turn it into a branded type. This type is just a string that has this additional brand for nominal checking. And then inside of this tokens file, what we do is we bring in that maybe current user ID. If there is no current user, then we return no tokens. Otherwise, we're going to want to get the Coinbase access token details and the MetaMask access token from our database, specifying that clerk ID as the unique reference to the user. And then if we do in fact have any Coinbase access token details saved, we can immediately run it through the refresh endpoint. And then we use this decode just to assert the type. Finally, we save the refresh token details to our database, and then we return the Coinbase and MetaMask access tokens. This DB right here is a pretty simple interface. Here's what it looks like. And we could swap this out with a real implementation of a database, but for the sake of this exercise, I just implemented a memory DB. I think one other thing worth noting is inside of the actual front-end code, anytime that we're interacting with our server, we can use this typesafe client. So if I were to omit a required field here, I would get a type error. We'll put this back. And another thing you'll notice is whenever we save our token successfully, on success, we're going to invalidate the balances query so that it's going to refetch it. I guess a final note to close on is I'm really excited about the use of effect, because we're able to not only encode the successful return type in an effect, but we're able to encode any of the possible errors that occur. So here we see this 401 and 403 response encoded as client errors. If we take a look at the app, and maybe let's add a return there, and I'll just show you what's within this pipe. We have an effect that encapsulates the errors that we want to expose from the server. I've kind of just chucked a bunch of errors in here willy-nilly, but the fundamental breakthrough of using effect is that we could handle these errors by using effect.catch tag, and then we have these completions. So there's this happy path for actually handling any of the unhappy path. And I think this could be especially powerful for our use cases because a lot of things can go wrong when you're doing a crypto transfer and you're interacting with different exchanges, and there are a lot of asynchronous processes happening all over the place. Things just go wrong. And if this is being implicitly tracked within the type system, then we have such a greater ability to predict and recover. So that's my spiel on the 1B1 exercise. Thank you so much for watching. Please feel free to reach out with questions, and I'm really excited to be working with all of you.